Honors Math 2 Unit 5 review for the fall final. I was just checking what we did last year, and this is good for everybody in this room to hear, including anybody who's listening to this at home. Last year, me and Mr. Vang, who are the Honors Math 2 teachers here at Buchanan, we decided that for the honor students versus the regular students, these four formulas you are going to have to know. We are not going to give them to you. You are expected to know how to find the sum of the interior angles. You will have to know how to find the sum of the exterior angles. You will have to know how to find an individual interior angle if it's a regular polygon. You will have to know how to find an exterior individual angle if it's a regular polygon. So the four formulas that we have in section 1 for unit 5 will not be given to you, just like it wasn't during the unit. But that wasn't the main idea of unit 5. It was just one of those sections where we gave you maybe 3 to 4 questions from that section. Now if you go to your final, since your final is going to have around 50 something questions on it, either 50 to 55, somewhere in that neighborhood, there may only be 1 or 2 of these. And so I'm hoping you remember how we figured out how many, what the angles add up to inside a triangle versus outside. If you need to go back to the 5.1 video, feel free to do so. The main idea of Unit 5 was on four-sided shapes. You learned what a parallelogram was. And because parallelograms had certain properties, there were 4 properties that you had to memorize. And if you forgot what they are, that when something is a parallelogram, the opposite sides are congruent, the consecutive angles are supplementary, the opposite angles are congruent, and the diagonals bisect each other. Those are 4 facts about a parallelogram that you needed to know. You also needed to know what the definition of a parallelogram was. It was where both pairs of opposite sides of a quadrilateral are parallel. And the majority of the problems in section 2 were on parallelograms, and then if you knew or you were trying to prove that something was a parallelogram, you had to do that in section 3. And then we went into special parallelograms. The 3 special parallelograms were a rhombus, a rectangle, or a square. Those special parallelograms didn't just have the properties of the parallelograms, they also had some individual properties. You needed to know that for a rhombus, those diagonals are always perpendicular, that each diagonal bisects their respective angles, and that the diagonals bisect each other. That was something unique to a rhombus, and since a square is a rhombus, these facts hold true for a square as well. For rectangles, the diagonals were congruent. The diagonals bisected each other. Those are true for a rectangle, and since a square is also a rectangle, those are also true for a square. And then squares, by definition, are parallelograms with 4 congruent sides and 4 right angles, had the properties of both of these 2 things above it, because these are considered also a rhombus and a rectangle. They are always those things above it. A rhombus, though, by itself has 4 congruent sides. Sometimes it's a rhombus, sometimes it could be a square if it also has the 4 right angles. A rectangle has 4 right angles by definition, so sometimes it's a square if 4 sides are congruent. We just don't know most of the time. That's why we said sometimes, that's why we said always, and we said sometimes never on those questions. And then you had to deal with conditions, where you had to be able to say which one was which, give things the most specific name. We added trapezoids and kites. Trapezoids were not parallelograms. They had only 1 pair of parallel sides. We talked about problems with isosceles trapezoids, where the base angles, both pairs, were congruent to each other, meaning the bottom base angles would be congruent, or the top base angles would be congruent to each other. These two things are still supplementary, meaning they add to 180. Kites, on the other hand, I almost forgot that. Kites, on the other hand, were where there are two pairs of consecutive congruent sides. These two are congruent and these two are congruent, and opposite sides were not congruent to each other, which makes it different than parallelograms or squares or rectangles. We also covered a small idea called the trapezoid midsegment theorem. This is different than Unit 4. In Unit 4, we had a triangle midsegment theorem. That was exactly half of the bottom. This is not half. This is the average of the top and the bottom. If it's the average, then the easiest way to solve these is to add the top plus the bottom is equal to double that midsegment, in case you didn't know. I think that's something that I almost overlooked. And if I think about what the whole chapter 5 was about, I would go to this picture because it had every single shape that we talked about. We talked about quadrilaterals and trapezoids and isosceles trapezoids. We talked about kites, talked about parallelograms, rectangles, rhombi, and squares. How sometimes what's below it, sometimes a trapezoid is an isosceles trapezoid. An isosceles trapezoid is always a quadrilateral, and so on. A rectangle is never a rhombus unless it is a square. A square is both a rectangle and a rhombus. So sometimes a rectangle could be a rhombus. It's the only one that's side by side with something it could be sometimes. This is the major idea of the chapter. Do you know all the properties? Do you know how to solve problems involving x's and y's? I saw something on the review while a student was asking a question that deals with systems of equations. You may have to review how to solve two equations when you have an x and a y in two different equations. That's going to show up on your final, I'll promise you that. Lastly, you could use proofs to prove any of those shapes. All you have to do is know your midpoint, distance, and slope formulas. If you want to know the midpoint, if you're trying to prove that something's diagonals gets bisected, if they have the same midpoint, then those diagonals that bisect each other will be the same exact midpoint. You could figure that out using midpoints. If you want to know if something is the same distance, like if opposite sides are congruent, you might need to know the distance formula if you're using two coordinates. If you want to know if things are parallel, you need to know what their slopes are. That's something you could use when you're dealing with A's and B's and C's and things like that. So that's the major idea of the chapter. The major idea of the chapter is knowing, really, those shapes with a few problems that dealt with coordinates, with a few problems that dealt with what are the sum of the angles, and so on. If you need any further information about any of those topics, feel free to go to those videos. That's where I'm going to stop.